Welcome to 10th in the series of videos on convex lens. In this video we're going to look at the use case of object which is object distance being lesser than the focal length. So let's see the ray diagram in terms of what happens when the object is close to F. We know that when object is at F, the image is formed at infinity. As we bring this object close to the optical center, we see that the rays are diverging. So for somebody who sees from the other side of the lens, the virtual image is formed by the brain, and you see a large virtual image of the object. Now let's see a demo of this.
And now if we bring this lens very close or beyond or very close, then this is lesser than the focal length, and in such a case you won't be able to get a real image. The image that you will see is a virtual image. To see this virtual image, we see it through our lens, and you can see how large it is, and you can't capture this image in a screen. And as I take this lens forward, which is closer to the candle or the object, you will see the size of the object is reducing, and it's becoming smaller and smaller. So eventually the size will become closer to its original size. But as you bring it back towards the focus, or more towards the focus, let's say in this case focus is 10 centimeters, as you bring it to 9 centimeter mark or 9.5 centimeter mark, you will see that the image formed, the virtual image formed, is really magnified. You can even see the thread in the candle, how it's burning.
Let's draw the ray diagram for what we just now saw. So this is a representative object, and let's take a small point in that representative object and see where the image will be formed. So let's first take a ray parallel to the principal axis, and this ray after refraction would pass through the focal point. So let's mark that. So the ray goes through the focal point, and let's also extend this a little bit, and in a moment we'll know why did we do that. And a ray that goes through the optical center will pass undeviated. So let's draw a ray parallel to the optical center. There you go. So here is a ray that goes parallel to optical center. Now let's mark these rays. And if you are seeing that object from here, these rays which are diverging, they come to your eyes, and your brain projects these rays and imagines that these rays for that point originated over here. So it creates a virtual image. So this is a representative point for what we have taken, and here is a virtual image that gets formed, marked as dotted line to represent that it's virtual, and mark the arrow. So if this was object, this would be your image. Let's imagine that this object distance is about -5 centimeters, and the focal length is 10 centimeters. So let's apply the lens formula to find where the object will be. Image will be 1 by V minus 1 by U is 1 by F, or 1 by V minus 1 by -5 equal to 1 by 10, or 1 by v equal to 1 by 10 minus 1 by 5, that's minus 5 by 50, that's equal to minus 1 by 10, or v is equal to minus 10. So we probably, we should have marked, let me erase this f and let me mark it here, because as per our equation, and that's where we get the image as. So this is our f, this is our 2f, may not be perfect marking, but yeah, that's where the image comes. So you pay attention to the minus sign that you got here, which implies that the image is in the left. The magnification is given by v by u, that is minus 10 divided by minus 5, that is 2. So if your object size is 5 centimeters, the image size is m times object size. So image size would be equal to 2 into 5 centimeters, that's equal to 10 centimeters. You see the magnification is plus and the I is also plus. So the image size is 10 centimeters, right? Because I equal to magnification into object size. Image size is magnification to object size. So the type of the image is, this is virtual. Now virtual and erect always go together, virtual erect, and it's enlarged. So let's revisit our learning goals. So we saw a visual demo, a ray diagram, we applied the lens maker's formulae and found the magnification. Please recreate your mental narrative based on what you saw in this video with absolute values and calculations, etc. And in case you get stuck, please see this video again. See you until the next one. Bye.